Okay, boy, there's so much here. I'm just trying to confirm everything's live. What I don't have is a good volume check. For some reason on my little monitor over here, the place where I normally monitor volume is not working. If you wouldn't mind putting in the comment stream whether or not you can hear me okay. Let's see. Otherwise, I think we're ready to go. Welcome to another Emerald Hills live stream. It's been some time. I think most of that has been, I've not been able to find any clear nights. Okay, good, Chuck. Thanks for that confirmation. But another factor besides that, I have been traveling some and just trying to find the nexus of a clear night when, you know, there would be the availability, I'd be in town. And welcome Chuck and Wendy and Jeff. Let me see if I can get at least here working on my phone. So far I can't, which is really sad. Trying to find a way just to see. Okay, maybe here we go. All right, that got it. Okay, so that'll help a little bit. At least I can see your guys' comments on my phone. Okay, tonight what we're hoping to do is to be able to catch back up and maybe just spend an hour or so together, catch a few targets. As always, we'll be using a RASA 11. It's an 11-inch Rowe-Ackermann Schmidt Astrograph, the kind with a camera on the business end of the scope. And that camera, let's see if we can get you to where you can see that. That camera is aimed right now at the North Star. Let's go ahead and jump to something that we can see here. We're working off of the 1001 Celestial Wonders that, you know, To See Before You Die book. And this is by Michael Bakich, if you've ever heard of him before. So let's go back and we're going to go over here to AstroPlanner and look for NGC 7788. AstroPlanner gives us an idea of which targets are up, and so let's try to slew to that object and see how things work. Let's see, I want to get you a view of the scope down there. Let's see if we can do that. Let's see. What we want to try to do is allow this. I tell you what we're going to do. There you go. So the scope has moved. Let's try to bridge this together with the other browser window I have open and see if that, there we go. So we're going to try to bridge this together with that. Hopefully that, there you go. That gives us a scope view at the bottom. Let's bring that in a little bit. Okay. And then let's do a plate solve just to see how we do with the night sky. This, of course, compares what the software, Sharpcap, was expecting to see in this part of the sky. You can see it made a 0.88 degree correction, which is not unreasonable for the first observation of the night, getting the scope kind of synced. This is an open cluster, and I guess this might be it right here in the middle. Let's zoom in just a little bit. It's not a very tight cluster, is it? Maybe this is the actual heart of it. You can see a little bit of a salt and pepper shape here. If that whole thing is it, it's a very loose cluster. I'll tell you what, let's go to our Stellarium and let's search for that. That's NGC 7788, NGC 7788. And this will give us an idea of what we're looking at here. Here you can see the actual field of view of our RASA telescope. So down here is the Widow's Web cluster, and here is NGC 7788 in the middle. Sure enough, it's kind of a loose cluster, isn't it? Just looks like these. Let's look it up and see what Bakich said about it. It's object 741. 741. And he says, this is one of the objects he says you should see before you die. 741. He says, NGC 7788 is the most northwestern of a line of 3 open clusters. The brightest magnitude at 8.5 is NGC 7790. I bet that's the Widow's Web cluster, I bet. Whoops. Boy, he doesn't say much about it. He says, though, it's magnitude 9, a size 4 arc minutes. We're in Cassiopeia. So anyway, there you have it, NGC 7788. I think we're just going to do a quick observation of it and move on to NGC 103. How about that? NGC 103. I'm going to look and catch up with you guys now. Chuck, Wendy, Jeff. Wendy says we hear you well. Clear nights have been absent here as well. Okay, so I'm not the only one. Chuck's had a hard time getting clear nights as well. We've got Winnie on from Magdalena, New Mexico. Thank you, Winnie. Good to be back. That's John L. Yeah, John L. from Magdalena. Mike, good to see you on from Atlanta. Larry, good evening. Good to have you back. And then we've got Laya. Am I saying that right? Laya, L-Y-A. And there's Steve and Eli. Yeah, it's been a while for sure. Thanks for coming back with us. That brings us to 15 or so. Mark, good to have you on board from Sullivan. All right, now let's go back to our live view of the scope. And see. There we go. We lost our, meanwhile, we lost our view, our scope cam, didn't we? What is up with that? There we go. Now we're back. Nope, that's weird. I'm going there, it's disappearing. That's odd. Anyway, let's do a quick plate solve here. Again, just to make sure we're in tune with the night sky. And this is also an open cluster, NGC 103. Let's back off just a bit to get the big picture here. We were right on target, 6/100ths of a degree off, it corrected. I'm going to turn on our Deep Sky Image Annotation, Alt-D there. Yeah, that's where NGC 103 is supposed to be. Boy, I sure don't see it there, do you? Let's turn that back off now and see if we can zoom in. Okay, maybe right here then. Very faint, and it feels like it's just a little bit out of focus. Several rich colors there. Just a little out of focus. I'll tell you what let's do. Let's pull the camera off of Sharpcap. Let's go back to Nina. I'd like for you to see how quickly Nina is focusing now anyway. take a look at this. I'm going to turn on the camera. Oh, and I have to go back over here, and I believe I have to turn off the, no, maybe I don't. Focuser also. Let's see if the focuser turns on. And it did. Okay, now let's go to imaging. Now watch how fast this focuses in Nina. Let's move this up so you can see the whole thing and watch it go. So let's time it, okay? Somebody start a stopwatch. I'll let you guys time it. You guys ready? Chuck or somebody. See if somebody can start a stopwatch. Okay, ready, go. Okay, we're not seeing a lot of action there, are we? I wonder if, oh, there it goes. So on the left, you see the picture that the Astrocam, which is a ZWO ASI178MM Pro, you can see the picture that it's taking of the night sky. And then on the right, you see the efforts that the software is making to try to figure out the focus. And the way it does this is it takes the first picture and measures kind of like the luminance of the stars. And the logic behind this is the more out of focus a star is, the more of a splotch it's going to create. And a wider splotch creates a higher luminance. So basically what the software is doing, as I understand it, is it's picking out the spot where the luminance is the smallest possible luminance, because it reasons that those are the places where the focus is going to be the most pinpoint. And you can see it's already reached a theory of where that place is. And every time it moves the focuser a little bit, in other words, it's moving the telescope a little bit to the left or the right of focus, to the in or the out of focus. Every time it does that, it measures that luminance again. And you see it's already formed an opinion. It thinks this is going to be the best focal point, right here at the bottom of this parabola. And what it does to check itself is it goes 3 or 4 stops, 3 or 4 positions past that, just to double check that it's right. And look how quickly it's decided, no, that really is the best focus for this part of the sky, this temperature, all the different factors, and get ready to stop the stopwatch, because it's going to wrap up here in just a second. It's going to decide, okay, that's the best. And how will we know that? This X will turn into a word down there. I think it says start imaging or something like that. Whenever that X turns into the word start imaging, it's done. Start autofocus. Okay, so stop your stopwatch. Actually up here, no, it just tells the time. So I hope somebody ran a, oh, here we go, the stopwatch. Is that really 2 minutes and 36 seconds? It did all that focus. Did anybody run a stopwatch on the stream? That, to me, is just incredibly fast. Okay, now we're going to go up and disconnect the focuser, because the rig only likes for one thing to be connected to the camera at a time, and one thing to be connected with the focuser at a time. So now we're going to turn the camera back on in Sharpcap, and you see it's automatically connecting to the focuser again. Now you see that's a little bit sharper, isn't it? We're zoomed in about 138%, so that's well past our optical zoom, and we're kind of using now what you might call the digital zoom. So this is a smaller, let's look and see what Bakich says about NGC 103. It's his object number 754. What do you guys think of open clusters? You might write something in the comments about what you think of clusters. A lot of people don't like clusters very much. They don't think they're very beautiful. Bakich says the easiest way to find our next target is to locate magnitude 4.2 Kappa Cassiope. Then he tells you how to find it. It says you'll spot about 3 dozen stars in a tight pattern magnification of 50x will set this object in a nice star field, triple the power. Look for arcs and hooks made by the cluster stars. Arcs and hooks. I do see this, maybe a slight arc here. Here's the hook. I don't know if you guys can see that. There is a hook here. Maybe that's another hook. There's a little arc. Barely, barely visible. Let's zoom in a little farther. Obviously, we're at 313% of our optical. So in other words, this is way into the digital zoom. But here's an arc. Here's a hook. There's a nice arc. Here's a little hook. So he's right. It is a cluster of arcs and hooks. Some observers have detected the Greek letter psi, formed by stars in the center. Psi. I suppose you guys who've had Greek, is this kind of like a psi here? Maybe a Christmas tree with a long trunk? Anyway, that's NGC 103. So let's do just a quick observation on it. Whoa, what did I do here? Let's go back. Here we go. Quick observation. Now let's go to NGC 896. So we'll slew there. Chuck's talking about the fact that it's 89 degrees outside. He doesn't want to go out and sweat there at the scope. So I don't blame you, Chuck. Fortunately, with EAA, with the telescope out there 200 feet away, we're able to sit here in 74 degrees inside the office at night. And we're talking to the scope via fiber optic cable. And the scope is out there, you know, out of our reach. So it's kind of fun, out of our reach in terms of physical, but it's definitely within our reach visually, huh? So there's the first screen. Now, this is a bright nebula, but I bet we're going to need to stack this. So let's go up to our sequencer here and say, let's do prep for imaging. Actually, why don't we plate solve this just to make sure. We were off of by a quarter of a degree here. So now the mount, the thing that the telescope is resting on, will synchronize the sky by changing the telescope a little bit so that we should now have, sure enough, NGC 0896 will be here in the middle somewhere when we get it to appear. But our exposures are just 3 seconds, and that's not going to be good enough to see this nebula. So let's go to our sequencer, and let's use prep for imaging only. And we're just going to put the name NGC 896 in our little form here. And then it's going to go through a little bit of a setup with its live stacking routine. And okay. Looks like everything's working okay. I'll let you see the sequence. Oh, it's finished the sequence now. So now we can do a, oh, right away, you can see that. So this was the kind of auto stretch, as they call it, down there in the histogram at the bottom. The histogram is this part down here that lets us line up these various thresholds so that we can make this a little bit more like we would like to see it. I might have that black level just a little too high now. maybe not. We're going to press the Shift key. That lets us make very fine adjustments. What we're trying to do here is get rid of the sky glow so we can just see the nebula. And boy, we saw it with the first 20-second exposure. These are 20-second exposures that we're doing here. What we want to do is see the cloud of the nebula without causing the night sky to just glow too much. This is a beautiful nebula. Look at this bright spot out here. Let's let that cook for just a second. And we're looking at NGC 896. Let's go over to Stellarium. And whoops. Let's back away so we can kind of get an idea of where we are. So it's keeping track of where we are now automatically. And that's really a lot better with this latest version of Stellarium. My friend Pete pointed out that now it's connected through ASCOM again. They've got it working now in version 25.2, so we don't have to go looking for things. It automatically lined up the scope. It lined up Stellarium with where the scope was looking. That's fantastic. I keep hitting Control. So we're really looking here toward the northeast part of the sky. So here's the north pole, so to speak. There's Polaris. Here's the northeast part of the sky, and right here is where we're looking. It's called, actually that's not it, is it? That's still on NGC 7788. We want to go to NGC 896. So there is our actual telescope field of view. And it looks like that NGC 896 is just this part of the overall Heart Nebula. And the Heart Nebula is it's huge, of course. But this little section here is what's known as 896. And the Heart Nebula appears not to have an NGC number. Must have been too dim for the NGC catalog. But let's go over to NGC 896 back in our live view again. So this whole thing out here is going to become the Heart Nebula. This brighter part is NGC 896. And this brighter part here is NGC 896. The wider part is IC 1795, which is probably more of the Heart Nebula. It's brought out here. We've observed the Heart Nebula before, but I don't think we've ever tried to look just at NGC 896. So let's see what our friend Michael has to say about NGC 896, which is just this part of the Heart Nebula. While that continues to percolate a little more, it really is beautifully red, isn't it? Fish head. Mark says it's the fish head part. NGC 896. It's object number 824. $824. It tells you where to find it. It's basically the bright condensation at NGC 896's. Oh, I see. That's to find 908. So he doesn't say much about it. He just says object number 824. How does he not say much about this? He says it's an emission nebula, bright condensation, and 8 minutes to the east-northeast lies the more impressive nebula IC1795, which he doesn't have listed. Well, this seems odd, doesn't it? Azray, good to have you aboard. So IC1795 is the Fishhead Nebula. Okay, so let's back off here and see if we can find. I can see why Mark says this is nicknamed the Fishhead Nebula. So that's the brighter part. At 7 minutes, it's pretty strong. And then this part here, as are lots of times objects that are separated only by a few dust lanes, this brighter part is NGC 896. Okay, I think I'm going to say make observation. See how fast this works here. Say this is the tip of the Fishhead Nebula, IC1795, brightest tip. Some background stars. Okay. Now the next thing we're supposed to look at is by the way, let's not move off this too quickly before we just appreciate that that's up there in the night sky all the time. It's just longing for somebody to pay attention to it. And it just sits up there and waits. And tonight, you've observed it. So again, what you've observed in particular is NGC 896, but you also saw IC1795, the Fishhead Nebula. Just going to save this, and for a moment, I'm going to search and see if IC1795 is in there. So what I've done is I've hit an AstroPlanner, I've hit Control F, IC1795, and it's not there. So why don't we go to wish list real quick. And can we add I see it's off. IC1795. It's not in it occurs in 10 catalogs. And we have never made a note on it. The Fishhead Nebula, we saw this in conjunction with NGC, was it 896, right? Yeah, NGC 896 and 1001 objects. It's much grander than NGC 896, but not as bright. So it didn't make Michael's list. But what do you guys think? I mean, arguably, one might say that the bigger nebula is actually grander, huh? So what we had to do there is we had to save that in a different list so we didn't pollute Michael's 1001 objects to see before we die. But it just seemed like if we hadn't done an observation of that, we should do it before we leave. Let's just do a quick save exactly as seen kind of picture of this. So it's basically saving a snapshot of that. And then let's end the live stacking. And the next object in our list, by the way, we're a half an hour in on our observing tonight. We're hoping to go for 1 hour. We started at 10:15, it's 10:45. That means we have a half an hour left. We've made 3 observations. We took a little more time on that one, but it was pretty cool, huh? Let's go to Eta Cassiopeia, and let's see, we're not seeing the scope, are we? There we go. Do you think it already moved? Is it that fast? Slew to object. Yeah, we're on it supposedly. Okay, so let's go back to our camera view. I don't know why that's blacking out the scope. We'll have to figure that out later. Oh, I bet it's this. So let's do a plate solve here, and hopefully it'll pull that star back over in the middle. This star right here, I bet, is Eta Cassiopeia, a multiple star system. Yeah, we were 1/4 of a degree off. Didn't see it pull it over. Oh, because maybe these are the stars, you think. I guess it did now. Yeah, it pulled it over. So in a moment, that one will disappear, and this one will be here, I bet. Oh, we're still in 20 seconds. 3 seconds. That'll help us. Okay, so this is our star system we're here to look at. And let's read about it and see what Bakich wanted us to see. 772 is the number in his list. It's a colorful binary. It is colorful. Look at the smaller star in the system. Has more of a reddish glow. Low power works best to bring out the yellow color. So let's get to that low power by maybe going to 1 second. So that does bring out the color a little better, doesn't it? In this, at least in the red. What if we go down to 500 milliseconds? Still not seeing a lot of yellow in that middle star, are we? You guys might have better color vision than I do, but I'm not seeing a lot of yellow there yet. even though we're at 500 millisecond camera views. Looks like Jupiter, Mike says, with a moon. You're right. Eta Cassiopeia. Reddish hue of the secondary. Magnifications above 100 times accentuate the brightness difference between the two, making them appear more white and yellow. That's what we have going on. Common name, I don't know how to say that. Achird, A-C-H-I-R-D, is a 20th century edition. Richard Hinckley Allen mentions the star as a nice double, but says nothing about the name in the 1899 book that he did, Star Names and Their Meaning. And that's basically all he says. So a lot of people get a big kick out of splitting double stars. I don't think the RASA is necessarily the best at splitting double stars. It has such a wide field of view. What is it? Is it 1.5 degrees? I forget. You know where we can see this is in Stellarium. Let's go to, can we just say Eta Cas and will it find it? No, it didn't. Let's try HD 4614. Yeah, there we go. So there's Achird, and here's our RASA field of view. It looks like it's 1.25 degree high by 2 degrees 10 minutes wide. So 1.25 by 2 1/6. It's a huge field of view. And it's not really great at splitting stars. Nevertheless, we are able to split Achird. And it didn't see much colorful stuff, did it? It's barely making this one yellow in the artwork that we have here in Stellarium. But it kind of matches what we're seeing, doesn't it? Here in our live view. This is the live camera now from the end of our RASA telescope. Okay, we're not stacking, so let's just run on to the next one, which is NGC 744. NGC 744. We've got about 13 or so people on the stream. If you haven't yet identified where you're observing from, if you don't mind telling us, it's always fun to see where everybody's observing from. And you guys are observing with me in this, so you're part of the team. Now we're headed to NGC 744, which is object 812. Object 812. And just, I'll take a second and let you see the way he does this. This particular book is a lot less text on any given page and a lot more charts and graphs and pictures. But the upshot of that is he's not really doing as much description as, say, some of the other books that we've used. So we're not getting quite as much. NGC 744, which is object 812. This is an open cluster again. Let's go back out to full auto and let's why are we not seeing as much? What are we doing wrong here? Just looks like there are only a couple of stars. This is at 24 degrees. Let's give ourselves maybe 10 seconds so we can see a few more stars here, enough to plate solve. Okay, that should do it. We're just 0.18 degrees off. Boy, is there a cluster in the middle of this picture? Let's go back to Stellarium and back off here. We're looking at a part of Cassiopeia here. Oh no, I'm sorry. NGC 744. So this is a part of the night sky that maybe just doesn't have as much brightness in it, you think? Let's try 15 seconds and see if we can pull out a few more of those. Let's go to our deep sky image annotation. Yep, right there. It's supposed to be right in the middle. All right, I tell you what, we're going to have to stack this. Let's run and this is NGC 744. The cluster has 140 stars. Something is not right, Mark says. You're right. Walter's on from Arkansas. Ray, good to have you aboard from Glendale. Wendy, you have a crown with the number 3. Does that mean the number of comments, maybe? You got a crown. Sarah Man is on from Florida. Oh, this is a lot more like it. A lot more like it. So it really helped to open up our aperture a little, didn't it? Now we instantly see this cluster in the middle. Ton of stars there. NGC 744, bright open cluster. The star count is relatively poor, however. A 12-inch scope and a 4-inch scope both reveal only 24 stars. The brightest nearby star, he tells that. Look for this cluster a bit more than 3. So he says only about 24 stars. It would be kind of hard to figure out which stars are with the cluster and which are just regular background stars, wouldn't it? So this is the center of the cluster, but it looks like it kind of strays out here some too, doesn't it? What do you guys think of open clusters? Are they pretty for you, or are you not that big of a fan? What do you think? All right, let's stop the live stacking. Let's go back to maybe 10 seconds, and let's go to the next object, which is 8, however you say that, Lacerti. Is that it? 8 Lacerti. There, we're over to our scope. So that's a live view of the telescope slewing to the new location. This is a security camera out there in the observatory, and you can see it's basically got night vision. And I like this security camera because it doesn't need infrared. it doesn't shoot any infrared up into the telescope's field of view. You can see a couple of glowing LEDs, just a, whatever you would call those, a wheat lamp or an LED. This is from our garage door opener kind of thing that closes and opens the roll-off roof on top of the roll-off roof observatory. And so that's just a tiny LED that you're seeing over there on the garage door opener. And these up here that you're seeing are the stars. So the security camera is actually showing you the stars. That's how sensitive it is. I love this. This is the WISE. This is the new WISE 3, I think it's called. By the way, we can turn on the outside noise. See if you can hear it. That's the actual outside noise of the night, sky out there. Mike says he likes open clusters. Mark says with a 4-inch scope, no camera, 140 stars. Walter from Arkansas. Anyway, let's go back to our new target, which is supposed to be 8 Lacerti. It was off about 0.6 degrees. So thank the Lord for plate solving. And there's our target. 8 Lacerti. Well, I say that the RASA is not very good with double stars, but look at it splitting that double star. Let's go back out to auto, and that's even just at a 2-degree wide view of the night sky. You can already see it splitting that double star. So let's read what he says. This is object 708 in his count. 708. It's a binary. It's a star-poor region of the night sky. One way to find it, he tells you how to find it. Any size telescope will split this pair. Both components are white. So this is one of the objects that he said you should see before you die. I don't know, but I think maybe his threshold is a little lower than what had to merit such a dramatic title. Why should you see this before you die? I don't know, but I guess it looks like 2 little headlights in a lamp in a car. Let's see. Mike says he likes open clusters. And Walter says, well, I like Pleiades. And Wendy says, it is loud out there. That's right. I think it's just a combination of the fan noise in the scope combined with the crickets and all of the night noises. But I think a lot of it, to be honest, is the security camera is picking up the noise of the fan inside the RASA. And that circulates the air to try to keep the focus a lot more predictable. Anyway, we have seen 8 Lacerti, so now as far as Michael Bakich is concerned, we are 1/1000th closer than being able to die. So we'll do a quick observation of this and head on to our next target, which is IC1470. So let's slew to that. IC1470. So there you see the live view of the scope. Now you see we're looking almost exactly as if the scope were a rifle, and we're looking right down the barrel with the scope. And I should say that's not exactly north anymore. I used to have the camera situated so that it showed exactly north, lined up with the barrel of the telescope. But I kind of like a little bit of seeing the barrel of the telescope, the actual tube of the telescope. I like seeing that a little better when we're off. Can you see that little blinking airplane or something going by there? That's what it looks like as an airplane, a jet. Anyway, we're lined up with the back of the scope now, the optical tube assembly, the proper name, OTA. And let's plate solve once again to make sure we're on with IC1470. We were about 0.34 degrees off, and so now our software will instruct the mount to make up that difference so that we actually are back on track now. And as you can see, we're not seeing much of this nebula without stacking. So we are going to live stack this. So we're going to say prep for imaging only. And it's going to ask us first off for what is the name. It's IC1470. This sequence is just something that over time we've put together on our own. It's not something that comes with Sharpcap, but you can design your own little sequences, and you don't really have to know how to code. You just use blocks of things and tell the telescope what you want. Tell the software for it's Sharpcap, so it's the EAA imaging software. Right there you can already see something very unique in the middle. Let's first do a couple of auto stretches here. We'll stretch for color as well. And that gave us a very good stretch. Sharpcap, in this case, Sharpcap is very reliable. The auto stretches were exactly the way I would have tried to arrange them if I were manually doing it. Now look at this bright nebula right here in the middle. That's what we're going to zoom in on. Isn't that interesting? Now that's 118%, so this is not a huge nebula. But boy, is it bright. It was visible from the first stacking. What an interesting nebula. It's almost like an elliptical nebula. Let's see what he says about this. This is object 722 in his numeration, but the designation is IC1470. It doesn't have an NGC number because I guess it was too tiny. It looked like a red star to the Herschels. 722. He doesn't say a lot about it. You'll find this nebula 5 degrees. He tells you where to find it. Through a 12-inch telescope at 200 power, IC1470 appears bright with a fainter extension to the southeast. So this must be the fainter extension. Boy, that's not very much that he said about it, is it? So sad. I'm curious about this nebula. Why is it shaped like this? I'm just going to do a observation. I'm going to say this deserves a lot more study. It almost looks like a planetary nebula in that it is how would you describe it? Somewhat round, but at higher magnification, maybe it is an H2 region being lit up by 3 background stars, the brightest of which we can see right here. But look, there are 2 other tinier stars. We're way into our digital zoom capabilities here, so we're starting to get pixelation. But look at this bright star here, and then these, what I think might be 2 tiny stars here. And I think that's what is causing this pattern. And I think this is an H2 region, a hydrogen 2 region, that's being backlit, not unlike a neon sign, basically. Wendy says beautiful. It really is, isn't it? Let's save this exactly as seen. This is just 4 minutes of stretching, or I'm sorry, 4 minutes of stacking, but it is already so beautiful. This nebula deserves a lot more attention than what we're going to give it tonight. All right, let's stop our live stacking here. We already saved a picture of it. And let's go to one last object. This will be our last one of the night. It's 11:11. We said we should stop at 11:15. This is NGC 133. It's another open cluster. This has been open cluster night. So let's slew there. NGC 133. While it's doing that, let's go back over to Stellarium. And let's go look at IC 1470. IC 1470. Look at that. Stellarium has zero artwork on this. It's such a nondescript object. You know what I think we should do? Let's dash out to Hubble for a second. And let's go to IC 1470 nebula. It's a bright H2 region located in the constellation Cephus, known for its reddish comet-shaped appearance. It is an emission nebula. It's often observed with telescopes and filters to enhance its visibility. It's associated with a molecular cloud is believed to be ionized by an O7 star, creating a blister effect on the cloud's edge. So that's exactly what it is. And I think, truth be known, amateur astronomers describe it as a small, faint, oval-shaped patch, comet-shaped. It can be seen with telescopes of 8 inches or higher, but you, with some telescopes, need these nebula filters, and we didn't. It was very visible to us without any special filter. We have a light pollution filter, but not a nebula filter. It's a large molecular cloud. It's being lit up by a young, massive O7 star. And I think it's got a couple of other stars. I think it's not just one. So anyway, what a beautiful pattern we were able to see there. The last thing we're going to go look at now is this open cluster. Let's go to about 10 seconds. And let's go back to our full auto. Once again. Not necessarily a You know what we didn't do? We didn't do a plate solve, did we? And we were off a bit. Mike says, great selection of items tonight. Walter says, I agree, Mike. Good to have you here. Heinchari, I think is the way you said it. H-E-I-N, Heinchari. Thanks for tuning in. Hein, might tell us where you're observing from with us tonight. Well, let's stack this really quick like. And we're stacking at 15 seconds. That should be enough. Oh yeah. Okay, so now we can make out this cluster in the middle. Let's turn on our deep sky image annotation. So NGC 133 is this cluster here. So right here. Looks like a forked stick or something. Let's see what he says about it. 757 is his number. He says, NGC 133 forms a nice triangle in NGC 146 and King 14. This trio of open clusters lies near magnitude, tells the stars that are nearby. Looks like a hook of 4 equally bright stars. A hook. I can see these 4 stars are equally bright. I guess he considers that to be a hook. So you know, an open cluster is just a bunch of stars that are traveling together, kind of like, it's kind of like, sort of like a galaxy, isn't it? It's just a bunch of stars that are traveling together. And over time, all of the travel has stripped away any nebulosity, and a lot of the other stars have gotten lost. So instead of looking like a disc shape or an elliptical or a globe, you know, it just looks like a bunch of stars. But we measure their speed by this effect that's similar to a train whistle that gets louder or higher as it gets closer. And we can tell that these stars are traveling together. But I guess it would be helpful if we could drop off all the other stars and just see the cluster that we're looking at here. Anyway, this is the last picture we're going to look at tonight. And I guess let's just appreciate one more time all the hundreds, or maybe that's 1,000 stars that we're looking at here. And once again, I always like to point out, I hope it doesn't bother you, how did these all get here? I know that it's pretty popular now to say that this all happened by accident, but here at Emerald Hill Skies, we usually close by saying, thanks to the God who made all this. And we believe he created this universe for us to be able to enjoy, and we're glad that you were willing to enjoy it with us here tonight. We hope you'll come back. We'll try to find as many clear skies as we can. We'll get that all-sky imaging camera, the SkyCam, we'll get that working again, Lord willing, and so you can see through that. Otherwise, thanks for being here. Thanks to our crew that you guys have been willing to comment, and that's always fun. If you're viewing this in the recording later after the fact, we're sorry we missed you, and we hope you'll subscribe and maybe click the bell so you can be notified. You can also go to emeraldhillskies.com, and there you can sign up for a mailing list. And we email you usually about 12 hours or even 24 hours before the live stream. You can get an email in your inbox that we're going to do a live stream. We don't solicit you or spam you at all. We just let you know the live stream's coming up. You can subscribe there, or you can go to YouTube and subscribe there and click the notification bell. You can configure it so you want to be notified when we're there. And if you liked what you saw tonight, and only if you want to, you could hit the thumbs up, and that way maybe this stream will be caught by others when they come back. I see a bunch of you are kind of signing off with us. Cat1125 saying thanks. It's actually our privilege to be with you, Cat. Larry, thank you for being here. Walter, thank you for being here. You're very kind to encourage. Thanks to all of you who have spoken up. We'll keep working our way through our book here, 1001 celestial wonders to see before you die, and maybe you can work through all of them with us. It looks like, let's do a quick observation of this one. So it's done. Beautiful hook of 4 equal stars. So once we've logged that one, it means we now have about 1,000, and we show 1,027 objects in his list, 552 of which have been observed at one time or another. So we've got 475 to go, and we hope you'll come back and look at all 475 with us. God bless you. Have a great night. We look forward to seeing you next time. Take care, and good night from Emerald Hill Skies. See you next time.